Hi there, welcome back with another video. Earlier we have seen the conversion of AC signal to DC signal. In this video, we are going to convert the DC signal to AC signal. Stay tuned. You are going to deal with high current, so be careful while doing the project. Before moving further, let's look at the graph of AC and DC signals. This is the graph of AC current, which is commonly used in home appliances, and this is the DC signal which we get from the batteries. This square wave is the output signal of our project. So we are going to convert this DC signal to this square wave signal. Please note that the output we are getting in this project is not a perfect AC sinusoidal signal. We can use this signal to light a bulb and fan, but not for TV, fridge and other sophisticated devices. With the help of IC 4047 and MOSFETs, we are going to convert the steady DC signal to a square wave signal. Here the MOSFETs works in push-pull configuration. That means if one MOSFET is in on state, then the other will be in off, and vice versa. The output will be filtered by this 0.22 picofarad capacitor, and this 20K pot is used to adjust the frequency. The transformer is used here to amplify the voltage from 12 volts to 220 volts. We are using this transformer in opposite direction, that is commonly known as step-up transformer. And finally, we get the output at these terminals of the transformer. Circuit diagram link and component list is given in the description below. Connect the pins 4, 5, 6 and 14 of the IC 4047 to the VCC. Connect the pins 7, 8, 9 and 12 to the ground. Connect the 0.22 picofarad capacitor to first and third pin of the IC. Connect a 20 kilo ohm variable resistor to pin number 2nd and 3rd of the IC. Connect 200 ohm resistors to pin numbers 10 and 11 of the IC. Make sure that the resistors are 0.5 rating. Connect their another ends to gate terminals of the MOSFET IRFZ44N. Here, heat sinks must be used with MOSFETs with the help of MOSFET fitting kit along with heat sink compound to dissipate the heat. By the way, it is a mica paper, which is a good insulator. Connect the source terminals of the MOSFETs to the ground. Connect the drain terminals of the MOSFETs to the transformer's 12 volt pins. Connect the center taper wire of the transformer to VCC. Place the components along with switch and socket on the MDF cardboard. Connect the another coil pins of the transformer to plug socket. Connect the VCC terminal of the circuit to switch and another terminal of the switch to battery positive pin. Parallelly, connect an LED with 20 kΩ resistor. The battery used here is a rechargeable one. Connect the ground pin of the circuit to battery negative pin. Connect the charging plug to the battery. Now the circuit is ready to use. Here I have connected an LED bulb with a 30 watts. And it works fine, but not as efficient when it compared with the AC signal. Thanks for watching. Please do subscribe to this channel. If you like this video, please give a big thumbs up. If you have any query, please do comment below. Thank you. Have a good day.